This video presents the derivations in the paper, Denoising Diffusion Probabilistic Models. The diffusion models contain two stages. In the forward pass, noises are gradually added into an image, and in the reverse pass, the noises are gradually removed to obtain the original image. The forward process is fixed to a Markov chain that gradually adds Gaussian noise to the data according to a variance schedule. A notable property of the forward process is that it admits sampling xt at an arbitrary timestep t in closed form. Here we present how to obtain the xt as shown in equation 4 in the paper. Next, we move to the reverse process and see how to get xt-1 given xt and x0. Using Bayes' rule, we have each term can be obtained by the previous equations. Then, we can write the probability density functions. Thus, we can get the probability density function of xt-1. We compare the probability density function, and can get the variance of xt-1. Similarly, we can get the mean of xt-1. Now, we have got the equation 7 in the paper, which gives the mean and variance of xt-1. Next we move to the training objective. We first get the left part. Then, we get the right part. The right part can be further reorganized. Then, we get equation 5 in the paper. Lt is a constant during training. And the same for L0. So we care about Lt-1. Here, we want to obtain the mean of xt-1 by model prediction. Note that the KL divergence between two Gaussian distributions can be represented by this formula. So we can obtain the KL divergence between Q and P. Then, Lt-1 is equal to equation 8 in the paper. Now, we want to represent the first term by the known variables. We first obtain x0 by the reparametrization trick. Then, we can reorganize the equation 8 in the paper into equation 9. Now, the first term can be represented by the known variables. Now, we can get equation 10 in the paper. The current loss function encourages the predicted mean to be close to the first term. Since xt is known, we want to predict the noise. Finally, we can get equation 12 in the paper, where the model is encouraged to predict the noise.